Okay. So I'm actually really excited to see that Eleuther AI has actually taken the next step in their GPT-3, not necessarily GPT-3, but actually GPT endeavor. So they've actually, one of their purposes is to make um, a alternative, or not necessarily alternative, maybe it's going to be overall they're going to sell themselves as a product that's standalone and doesn't have anything to do with OpenAI's GPT-3. But the idea is that they released GPT-Neo like 3 months ago, and it was the first publicly available alternative to GPT-3, though not as powerful, but trained on more higher quality data. But now they've released a GPT, so June 9, and now it's June 11. They released a GPT-J-6B parameter model, which is trained on the very high quality pile dataset, which I reviewed in a previous video. And they say that this model performs similarly in downstream tasks to both GPT-3 6.7 billion and the Curie model accessible via the OpenAI API. And they give more, they give a few links here in their Discord channel. In the announcements, you have a collaboratory notebook for inference, a web demo, which we'll be looking into, which is the purpose of this video, and we have a blog post which is the release. So this is actually the playground, and this is actually the blog post. So GPT J6 billion JAX-based transformer performs nearly on par with the 6.7 GPT-3 Curie. So Curie is the second most powerful OpenAI GPT-3 model. So if we look in the playground over here, we can see that we have Da Vinci, which is the most capable and most powerful, and Curie is the second best, so it's very capable. And its strengths are language translation, complex classification, sentiment analysis, and summarization. And of course, you have the other less powerful but very efficient, which are Babbage and Ada, and the newly Instruct models, which are Curie and Da Vinci Instruct Beta. So, back on track. This library also serves as an example of model parallelism with XMAP on JAX. Okay. Is the best performing publicly available transformer in terms of zero-shot performance on various downstream tasks. Allows more flexible and faster inference than TensorFlow plus TPU counterparts. So they take a different approach versus other models. And requires a smaller amount of person hour that all other large-scale model developments did. Therefore, their approach JAX plus XMAP plus TPU is the right set of tools for quick development of large-scale models. And two of the people who have contributed a lot are Ben and Aaron, and of course, everyone else at Eleuther AI. And the other folks here. And then we have in this blog post that there's the model design. So it was trained on 400 billion tokens from the PAL dataset, which with 800 gigabytes of text. Again, look into the video on my review on the PAL dataset. Efficient attention was not used for simplicity. The dimension of which attention had, so this is actually the infrastructure of the transformer model. They talk about infrastructure here, the details of the infrastructure, the performance, more statistical data, and then we have sample outputs. So we have arithmetic here, which is one of the weakest points of GPT-3, but it's a stronger point of Neo model or GPT-J, since it was trained on the same pile dataset. The pile dataset consists of a subset of mathematical data. Therefore, it has mathematical superpowers. So this is a stronger point versus GPT-3. So we have theorem proving, natural language understanding. So you give it a prompt, ask it a question, and it gives you an output. Of course. Fun facts about geese. That's interesting. Alright, let's look at 2 or 3 examples in the playground. As far as I can understand, it takes like 1 or 2 minutes to run a completion, but I'm really curious to see when they're gonna release, if they didn't actually release the training weights on Hugging Face, which you would be able to actually access via the API inference on the Hugging Face API, which is something that I've used in the past, and it's faster. It's not as fast as GPT-3. Like if you ask something, if you ask GPT-3 something, for example here, like number 1, and then it just starts doing stuff immediately. But the API inference from Hugging Face, depending on the models, can take like much more time to completion. So anyways, let's this is our blank canvas, so let's start thinking about stuff. We could, let's see how they compare actually, right? So we have the DaVinci Instruct Beta. Let's do a head-to-head comparison. They said that J-6B is somewhat on par with Curie. So let's do a head-to-head comparison. A list of fields and areas where natural language processing can be used successfully. We have a temperature of 1, which is very high. Let's actually do it 0.5 because we need somewhat more factual data. We have frequency penalty, top P1. Let's try to use the same parameters over here. So temperature, you can go higher than 1. That's interesting. So temperature 0.5, right? So 0.5, top P, let's do it 1. And then let's actually run the same prompt. So a list of fields and areas where natural language processing can be used successfully. We have a warning here. Your text ends in a trailing space, which causes worse performance due to how the API splits text into tokens. Sorry about that. Do it again. Well, I'm not sure how good this is. Whoa. So content curation, data extraction, data enrichment, data integration, data preparation, a lot of data here. Data processing, data quality assurance, data visualization, document classification, and then it goes on and on and on, because right now we don't have any parameter here that we can actually toggle or play with so that we can control for frequency in the output, as we have here the frequency penalty. So it seems that Curie is actually doing better here because it gives us speech recognition and understanding, and then it explains what that means. Speech synthesis, this involves converting a sentence of symbols into an audible utterance. So this is +1 for Curie versus 6B. Let's try something different. Let's try actually on the superpowers of this. I don't want to be biased over here. So we have the prompt, what is 75 times 10? Let's actually do something more interesting. Let's say x plus, let's try to do something even more complicated. X squared plus 2x, x squared plus 2x minus 1 equals 0. Solve for x. And this is our prompt. We'll set the temperature even lower because we want more factual data. Let's actually do 0.1. Should be to 0, but let's try with 0.1. And let's give the same input, exactly the same input to Curie, set the temperature to 0.1, and the response length is 200, so it's enough. X squared plus 2x minus 1 equals 0. X equals minus 1 over 2 plus minus 1 over 4. I don't think that's the right solution. And J-6B didn't do a good job here either. Let's see, x squared plus 2x minus 1 equals 0. So we have minus 1, the solution is minus 1 plus minus square root of 2. This is nowhere near. Minus 1 over 2. The solution is minus 3. So no, this is not good. So the both output is bogus. Let's actually do, so this is 0 0 for both of them. Let's do another one. So we'll actually do something similar here. Let's say very basic arithmetic. Ten times 193 plus 6 times 1. So this would be equal, this would actually be equal to 1936, right? 1936. So, in this case, let's actually ask it, since this should be an instruct model. What is this? We copy the output, run the model. So definitely 0 for Curie. We're waiting on J-6B. J-6B didn't get it right either, so it says 1930, and in fact it's like 1936. Well, a little bit disappointing. What if we ask the same? What if we toggle the parameter, leave the temperature to higher, which is not good, but it should, if we set the temperature to higher, let's actually set both the temperature lower and the top P lower. Usually the idea is to toggle just one of them and leave the other the same, but let's just make an experiment here. So top P, both top P and temperature are 0.1. So still 0 here. 0 points. And we get basically the same result here. 0 points. What if we do this exact same one, which is the most extremely simplistic of them all? Does it say what temperature did they use? It doesn't. So we do this with Curie. Curie finally got it right, and then it starts confabulating, saying that 75 times 10 equals to 750 times 10 equals to 7500, which doesn't make any sense. And then run this one as well. So I think with this completion, I'm actually going to end the video, and I'm gonna do more head-to-head comparison with these. I could also try the instruct Curie instruct beta, see what we get. This is cleaner, so, and it got it right. So this is another point for Curie. And then we have another point for, we have 1 point for 6B as well, so it also got it right. We can just neglect whatever it outputted afterwards. And in this case, when you have more control over the model programmatically, you can just restrict the output to whatever amount of tokens you want. So in this case, both of them got it right. Now I'm really curious to actually keep on experimenting with both of these models head to head. The idea is that I'm very excited about the thing that folks at Eleuther are doing, as well as further alterations or further enhancements of GPT with more billion parameters, because I see there's a lot of potential in this, especially when they're actually doing a very good job on training the model on the high quality pile data set. Okay, that's it for this one.